Understanding program counter operation. A computer program is made up of a sequence of instructions. Some instructions are longer than the others. The computer program is stored in the program memory. The program memory has a limited width. If an instruction is too long, it may have to be stored in separate locations in the program memory. Let's indicate the addresses of the program memory. Instruction number 2 is a long instruction. It may take up 3 separate locations. A short instruction may take only one location. Let's use a robot to represent our CPU. The CPU has a counter called the program counter. The initial content in the program counter is 0. There is also an instruction register. Let the CPU start to operate. The first step of the operation is to fetch the instruction from the program memory. Instruction is fetched from program memory location indicated by the program counter. The current counter value is 0000. The instruction from program memory location 000 is fetched and placed in the instruction register. At the same time, the program counter is incremented by 1. The CPU goes into the decoding cycle. Only half the instruction 1 is received in the instruction register. The CPU is not able to execute this incomplete instruction. The CPU goes back to the fetching cycle. Instruction is fetched from program memory location indicated by the program counter. The current counter value is 0001. The instruction from program memory location 0001 is fetched and placed in the instruction register. The program counter is incremented by 1. The CPU goes into the decoding cycle. The instruction in the instruction register is complete, and the CPU executes the instruction. After completion of the execution cycle, the CPU is ready to fetch the next instruction. The next location for the instruction fetch will be at program memory location 0002. The instruction is placed in the instruction register. The program counter is incremented by 1. The CPU goes into the decoding cycle. The instruction is not complete. The CPU goes back to the fetch cycle. The fetch location will be 0003. The instruction is placed in the instruction register. The program counter is incremented again. The CPU goes into the decoding cycle. The instruction is still not complete. The CPU goes into the fetch cycle again. Next instruction shall be fetched from location 0004. The instruction is placed in the instruction register. The program counter is incremented again. Notice that the program counter is incremented after every instruction fetch. The CPU goes into the decoding cycle. The instruction is decoded. Assuming that the instruction requires a jump to instruction 5, which is located at program memory location 0008. When executing the instruction, the CPU changes the content in the program counter to 0008. Execution is complete. The CPU goes back to the fetch cycle. The next instruction we fetch from program memory location 0008. The instruction is placed in the instruction register. The program counter is incremented by 1. The CPU goes into the decoding phase. Only half the instruction 5 is in the instruction register. Execution is not possible. The CPU goes back to the fetch cycle. Instruction at location 0009 is fetched and goes into the instruction register. The program counter is incremented by 1. CPU goes into decoding phase. The instruction is complete and the CPU executes the instruction. Summarizing the CPU operation. Instructions are fetched based on the indicated location stored in the program counter. After every fetch cycle, the program counter is incremented by 1. If the instruction is not complete, additional instructions are fetched. If the instruction is a jump instruction, the CPU changes the content in the program counter to indicate the next location for instruction fetch. The program counter always holds the address of the next instruction to be executed. The operation can be summarized using a flowchart. The initial content in the program counter is 0000. The CPU fetches the instruction at program memory location indicated by the program counter. Program counter is incremented by 1. In the decoding cycle, the CPU determines if the instruction can be executed. If the instruction is incomplete, the CPU goes back to the fetch cycle. If the instruction can be executed, the CPU executes the program. If the instruction does not involve any jump, the CPU goes to the fetch cycle. If the instruction involves a jump, the CPU changes the content in the program counter before it goes back to fetch cycle. This operation is called a fetch, decode, and execute cycle.